Well, I can tell you what it is. The answer is, this is 146, number 6. Oh, wait a minute. I don't have an answer for it.
Yeah, just tell us the answer first. I did it. I think I did it right.
Oh, shh. This is a free response. So I need you quiet. Let's go through this. All right? It says the figure above shows the graph of the derivative. So the first thing you have to identify any time you have a graph given is, what is it? Is it the original? Is it the first derivative? Is it the second derivative? And it does something, this is 2, and it does something like this, and then something, this is 3, like that. All right. So it says it is wait a minute. So now it said we have a derivative, but f is continuous. Is the derivative continuous? No. No, but what is continuous? The original. F is continuous. And notice it had a closed interval 0 to 4. We might have to talk about that. For what values is f increasing? How do you look at this graph for increasing? Anything above the x-axis. So it's going to be 0 to 2 and 3 to 4. Do you paid attention to your whatever you want to call that, interval? Yes, I am. Okay. For what value of x does f have a relative minimum? So what I would do is I would kind of draw this picture, and you've got 0, you've got, bless you, 2, you've got 3, and you've got 4. So from 0 to 2, you're increasing. From 2 to 3, you're decreasing. And 3 to 4, you're increasing. Does that make sense? Yes, sir. So part B, there's a minimum where? X equals 3. At x equal 3. Did they ask you to justify? Ooh, they did. Now, this is f, correct? So you say because f prime of 3 equals 0, and what? F prime of x. You either say changes signs, or you tell me changes from negative to positive. All right. For what value of x do we have a relative maximum? And right there it is, x equal 2. So you've got a maximum at x equal 2. Yes, sir?
Does it matter that they're not connected?
No, because the function itself is continuous. So this is, yes, so we'll say f prime of 2 is what? Undefined, not equal to 0. Undefined. It's undefined because there's a gap. And f prime of x changes signs, or in this case, you would tell me changes from positive to negative. Now, D says if f of 1, if f of 1 is equal to 1, you are to use your answers to A, B, and C to sketch the graph just from 1 to 4. Okay? So this is a derivative, correct? So we know, let's talk about 0 to 1. We know the graph is increasing. And what kind of concavity? Down, because the first derivative is decreasing. From 1, we don't need that, do we? Okay, so from 1 to 2, the graph is still increasing, and it's concave down. What about 2 to 3? Decreasing and concave up. What about 3 to 4? Increasing because it's above the x-axis, and it's still increasing, so it's still concave up. So if you were to graph this, and you would have done this on graph paper, there's 1, 1. There's 2, there's 3, there's 4. So I would have started here, and I would have, from here, increased concave down to 2. Then I would have decreased concave up to 3. Then I would have increased concave up to 4. Yes?
How did you get the concave up and concave down?
Okay, when you're one derivative away, how do you look at the graph? Increasing, decreasing. Okay, if the derivative is increasing, then you're concave up. If the derivative is decreasing, then you're concave down.
Okay.
Does that make sense? Yes, sir. Yes, you can see my graph again. If you Give me a minute. Is that, well, I have a sweatshirt on.
You're never
Usually I have a sweatshirt there.
always cold. Strange. I know, right?
The derivative does not equal, I mean, the derivative is undefined because of a sharp turn. Okay? It is continuous. The derivative isn't continuous, but my graph is. They said f was continuous.
I love your eyelashes.
Thank
wow.
you. Thank you.
Those look great.
Cupid.
And crafty.
Alright. So here we go. Let me get put back together again. Alright. Is that finished?
Yep.
Alright. So now we are going to 150, number 4. Do you need that?
Yes.
Seriously?
Oh, I got it.
Oh, you know what?
I got it.
The way they wrote C, D is confusing. Do you agree? Let's talk about C and D. C. C says the absolute value of x is greater than or equal to 2. What does this mean? This means that x is greater than or equal to 2, or the opposite of x is greater than or equal to 2. Now, how do I solve for x? And what happens to my sign? Okay, so this right here means x greater than 2 and x less than negative 2. You see that? So let's do this again. Let's try D. D is only increasing. All right, so now they have absolute value of x is less than or equal to 2. So how do we do this from what we just did? X is less than or equal to 2, or opposite of x is less than or equal to 2. And then you solve this one, which gives you what would be negative 2. All right? So just FYI. We'll come back to these. Right now we have to look at our, if I want, it's all about increasing, decreasing. So what derivative do you need? So y prime, do you agree that's 6x squared plus 24? Okay. So did you set this equal to 0?
Yes.
All right, and when you do that, aren't you going to get a negative number?
Yeah, and you can't do a square root of that.
All right, and so now we're going to get negative 4. Can we square root that? That means there's no critical numbers. So if there's no critical numbers, that means it's either always increasing or always decreasing. So let's put in 0. That's going to be 24, so it'll always be positive. So it's always increasing. So it's A. Pardon? What, Haley? I did too. I like this. Okay, what about 5? Do you need help on 5? Okay, this is the derivative of a what kind of function? So we've got x squared plus 2. We've got 2x plus 1. And this is for x is less than or equal to 1. And this is for x is greater than 1. And we want f prime of 1.
So just find the derivative of the one that includes 1.
So what's the derivative? Isn't it 2x? And isn't it 2? This is for x is less than or equal to 1. And these are for x is greater than 1. So now we need the derivative at 1. So this is going to be 2 times 1, which is 2, for x is less than or equal to 1, and this is going to be 2 for x is greater than 1. Now, these answers must be the same for the derivative to exist, because remember the derivative is a limit, right? So in order for a limit to exist, the left must equal the right.
I thought they were looking for the derivative at 1. You just use the x
It would-
equals 1.
That's what I did.
Nope,
Yeah,
nope, because
it worked for me.
it's a piecewise function, and on a piecewise function, and we're doing it at the breaking point, it's a limit. It's got to be the same both directions.
Oh.
And then or the answer's not fine. They never have.
Oh.
Sometimes it won't work.
I didn't really think.
Okay, So now we're going to, that was 4, 5. 153.
Wait, what's that?
What's the answer? I don't know. C. We're going to 153, number 11.
Can you do that one?
Okay. This is not a skip. No. How many people turned in their Riemann sum worksheet on Friday?
Oh, I have it.
None. Very few. So we're going to stop right now. In fact, I will pause this
We have
because I need it.
So, Miss Bright, I have a question. Are we going to have to do the integrals with the numbers on the top
No.
now? Okay. So we don't have to do page 153, number 11?
Number 53, 11. Yes, I still, yes, you have to do this. Yes. So,
No, it has the weird numbers.
yes, because it's not asked. Shh, just shows you the graph. Hi, Deb, you're quiet? No. Then who's talking?
No, I'll be quiet.
Thank you. All right, this is 1, and this is 4, and this is what your graph does, correct? All right, so this right here is saying the integral from 1 to 4 of f of x dx. And this is the exact area, okay? That is the exact area. Then we have a left Riemann sum. What does that mean? That means that left rectangles are on the curve. Is this an under or overestimate? It is an underestimate. What are they asking? So anyway, I'll just talk and then we'll read the question. Left is an underestimate. Okay, what about the right? If we look at the right, if I were to come up here and do a right rectangle, what do I know? It is an overestimate. So I'm thinking they're asking, oh, midpoint. So if we look at midpoint, maybe I can get rid of the blue. Oh. Well, I'll try to erase. If I can find my eraser. All right. So, wow. All right. I'm just going to erase it all. I'll just draw it again. So now we're going to do a midpoint.
So midpoint's going to be an overestimate too.
So 1, 2, 3, 4. So midpoint would be like this. Did they really just do that to us? All right. We really needed another one. So we really couldn't do, but that would keep going, but we'd get the same idea, correct?
So that'd be over.
I would think it's either going to be, it's over or under.
That's kind of important.
Yeah.
Well, it's more over.
Okay, we're looking for the least value. All right, let me ask you this. Do you think it is closer to left versus right?
Trapezoid yet.
Oh, what about trapezoid?
So it's gonna be closest to the exact.
Yeah, trapezoid's gonna be.
Trapezoid's going to be, but is it over?
It's going to be
No, that's the same. It's like.
a little bit under, but not as under as left.
Is it under?
Yeah.
I don't know.
You tell us.
Okay, well, let's look. Here it is. The only way we're going to be able to see it is to make a big trapezoid. Is that over or under?
That's over.
That's over. So the trapezoid, that's a trapezoid.
That is a lie.
That's a trapezoid. Okay, so the trapezoid is over, but it's very close. The trapezoid is very close to the integral. Okay, it's over, but it's the closest. Midpoint, I would probably say, is the next closest. We know that right is over, and the only one under is what?
Left.
So what's the least?
What
Left.
about the derivative? We didn't do the derivative.
We didn't have to do the derivative.
Okay.
Mm-mm.
A was.
Answer A was not the derivative, it's the integral. This is the exact area. Oh, so the integral would actually be, oh darn. The integral would actually be here. You've got over, 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 exact, under.
Wait, what does the integral have to do?
It's the exact area. When we integrate, we're going to have the exact area.
Okay, so the answer would be left.
The answer would be left. All right, so that was 153. 160, number 25. 160, number 25. Want to talk about that?
Yeah.
Okay, so this is testing your understanding of some basic theorems and definitions. It says f is continuous on the closed interval AB. Which of the following statements are not necessarily true? Now, when you have a closed interval and it's continuous, what are you surely guaranteed? A max and a min. What is that called? Extreme value theorem. Okay, EVT. All you have to do is be continuous on a closed interval, and this is guaranteed. It occurs at the endpoints, if you want a little review here, or the what?
Critical numbers.
Critical numbers, one of those two.
Oh,
All right.
so it would be 1, 2, and 3.
So 1, yes. 2, yes. Now 3. It says f prime of some number between a and c must equals... Oh, okay, so what we're saying is 1 and 2 are true. Okay. Okay, so we know 1 and 2 are correct, but let's talk about why. Just because there's a guaranteed max and a guaranteed minimum, there's my max, there's my min. This is all about a relative. Do I have to have a relative max or min? No. It could happen at the endpoints. That is why. Because when the derivative equals 0, you're either doing this kind of turn or that kind of turn. All right? Is that what?
Isn't that like one of the theorems that like has...
That would probably be slope of secant equals slope of tangent, mean value. But there's nothing telling us that the secant slope is 0.
But like intermediate value?
Intermediate value theorem says that if you have a y value of 1 on the left side and a 10 on the right side, that you have to pass through all those numbers.
It says that C is the only correct one, though.
That-
Number 3 is the only correct one.
That because it's the incorrect one. C is correct because it's incorrect. How's that for confusion?
Got it.
Got it? It's correct because it's incorrect. All right, 167.38. All right, so this is one of those problems. No, you do have to do, but I think this is the calculator part. It is the calculator part, okay? So you're only going to have non-calculators. So what we're going to do, no, we're going to go ahead and we're going to do the derivative. What's the derivative? How do we do the derivative of 1/3 sine 4t?
Oh, wait, I got this.
1/3, chain rule,
1/3 cosine of 4t
times, good,
plus 1/8
1/8.
4t.
But isn't it going to be negative sign?
No, because it was minus sign, so it's
Just kidding.
or minus.
Okay, 4t times, so this is going to be 4/3
Sine of 4t.
cosine of 4t plus 1/2 sine. What were they asking on this?
And they need the double.
How many times does acceleration change from negative to positive in the first? So now we have to do the second derivative. What's the second derivative?
Negative 4/3
Negative 4/3 sine 4t times what? Times 4.
plus 1/2 cosine
Plus 1/2 cosine 4t
times 4.
times 4. So you're going to end up with negative 16/3 sine 4t plus 2 cosine 4t.
And that's where I lost it. I don't know what to do.
Now at that point you put this in your calculator.
Oh.
1, 2, 3, 4, 5? No, because you're assuming that it changes on the integers, and it might not change on the integers.
So what do we do?
Well, at that point we're done, but let me show you what we would do. All right, so we are going to, it'll be up in a minute. Open, I don't want to open. Kurt, can you be quiet so she can listen? Please.
No, I was just saying.
So what would we do if it was a non-calculator one?
Oh, it would be doable. Then you'd set it equal to 0 and do a chart. Did you hear what her question was? What do we do if it's a non-calculator one?
Are you going to give us a non-calculator like this, though?
I don't know.
So Miss Bride, we would just set up a chart,
A concavity. Well, wait a minute. Yes, a concavity chart.
and so you would do like 1 to 2, 2 to 3, 3 to 4.
No, you set this equal to 0, and then wherever it's 0 is where you.
Oh, that'd be the only changes would be at the critical numbers.
Well, but it's not technically critical numbers because it is. Is that sign equalize?
Second derivative.
Yes.
Right.
Gotcha.
It will. We're good because order of operations. It's all multiply.
We're not gonna have anything like this though, you said, because
Oh, a trig derivative? Yes, you could.
we have to use the calculator. We can't use
That's tangent. No, it won't be required calculator, but I certainly could put this on and ask you to do the derivative.
Yeah.
And that might have been one of the reasons why I included it, because it was trig chain rule. And I might not have been able to find another one. So if I were to graph this, actually, on here, look how I'm being smart. I'm going to my window, and what did they say? 1 to what? 5. So why would I want to?
Isn't it 0? Did you put 15?
I know I did. Delete. Didn't they say, was it 0 to 5? Okay, so we want 0 to 5. There you go. All right. So I'm going to hit enter, maybe. Gosh. All right, and now we're going to graph. So all we're seeing. So the question is, how many times does the acceleration change from negative to positive? How many times? 1, 2, 3. From negative to positive.
Oh, only negative.
Only negative to positive. All right. So then we're going to go to, that was 167. Now we're going to go to 169, number 43. Ooh, look at this table. It says f is differentiable, which means what? That it's also continuous. Table below gives the values of f and its derivative. Which of the following statements are true? All right. They're telling us that at x equal 2, the function is increasing. True or false? How do you know? At 2, f prime is positive, okay? There's a relative minimum in the interval, -1 to 1, but not necessarily at 0. True or false? Yes. Because the derivative at -1 is -2, the derivative at 1 is 2. Because of a change in signs, it must have, if it's continuous, remember, it must have a minimum. So now on 3, there's a relative maximum in the interval -1 to 1. Let's see.
Positive, right?
We have f of 0 is 1. We have f of f of 0
Well, it's just which
is
one
bigger
not
than f of
necessarily true,
-1.
We're like which ones are definitely true. And that one's not definitely true.
There is a relative maximum in the interval.
Well, 2 is true. Why?
We've got,
Because you can't have a minimum.
It's an interval.
Because I mean, like they have the numbers for it to be a minimum, but they don't necessarily. Like they could in between. Wait, why is 1 not true?
okay, we're looking at f of x for this. You ready? Look. You are at 0 at -1. At +1, you are at 0. You tell me how at 0 you're at 1, and you connect from here to here without there possibly being a maximum. There's got to be a maximum. There's a minimum in the interval. There's also a maximum in the interval. They didn't tell us specifically where it was. The maximum could be at 1.
0, 1 would be the maximum. Yeah, I thought so. Wait, look at f of x.
Okay. So now we're going to go to page 170.
These are so roundabout. I don't like these.
170 is 44. They want to know is when is the velocity negative? What do you have to do? First derivative. This might have to be, all right. Well, but let's stop. Just because it's in the calculator section doesn't mean you have to use a calculator. Well, the first time I did a multiple choice test that was an old one, I was amazed at how many calculator questions didn't require a calculator. That's a 6. Cosine pi t. So this is going to be 3t squared plus 22 plus 6 pi sine pi t. Does that make sense?
Yeah.
So, again, I probably put it in there for the chain rule of sine, but yes, to do this one does require a calculator. So just to prepare you, just for some fun here, we are going to go to y equals, we're going to clear this, and we're going to type in 3, and then we've got, I can't find my cursor, there it is, x.
Can you make it any bigger?
No, I can't. Squared. I don't believe I can. Let me see. See, it won't pull. Well, this isn't the Cadillac, you could say. This isn't a TI version. Plus, actually, some really smart person did this before TI even did it. Where's the pi? Is it above the divide? Does that look like pi? That's an E.
Yeah.
Okay. So, equalize, where's my pi? It's got to be above there then. Is that pi? There we go. 6 pi sine. What did I just say? That's a comma. Sine, and then we've got to do pi again. But at least I know where it is. So much easier to work this. The caret, right? X. So now, what are we doing here? Time before 0. So I'm going to go back to my window. Remember I played with my window? And I'm going to take this back to 10. Why did I not go past 0? Right, it's a greater than 0. All right. And I see, for what value of t, if any, is a velocity negative? What does this tell me? The velocity is never negative. Now, technically, should we probably figure out if it goes way low? Okay. All right, so you're going to take my word for it. All right, 203.38.
That's it? What's the answer?
It was
Oh.
203. The work I should see is that derivative. All right, 203. Did you like 203?
Oh, yeah, I did like to.
Okay, anybody with questions on 203?
Yes.
Okay. It's these type of questions that my kids in the past have done well on. And I think it's because of all that curve sketch worksheet we did. Now, where am I supposed to go from here? I'm here.
212 divided 3.
True. Okay. Well, anyway, it says a figure above, oh, this is a what? Second derivative graph. By the way, f original is continuous, okay? And the following statements, are they true? F is concave up for x is less than 0. How do we look at a second derivative graph for concavity 2 derivatives away? Positive, negatives. Is that a true statement? They're saying here and here. Yes. All right, part B, or letter 2. Number 2. F has a relative maximum between B and C. This is B and this is C. And again, this is F.
Concave up, so it has to be a minimum.
This is concave up. So if anything, there's going to be, but can we really tell from this?
Well, the thing says maximum.
So this has a relative.
So there is no maximum.
There's no max. It goes from negative to positive.
Now that's going to be about the, in order to know if there's a max or a min, you have to know if there's a critical number, and there's no way the second derivative tells us if there's a critical number. Now we can tell if there's a max or min on the first derivative from the second. So I say 2 can't be determined.
I was just thinking because it's always concave up, so it has to only have a minimum, I thought. It can't have a maximum.
Concave, you mean concave down?
It's concave
Oh, the original is concave up. Okay, but look at this. Hold on, I didn't do a very good job. Where's the minimum? Okay? So if you can do a counterexample, then we can't say so. F has points of inflection. Now, can we do that? At 0 and B. Okay, because you've changed from positive to negative and from negative to positive. So 1 and 3 for sure. All right, so now 212 must have been another free response. Am I correct? Did you like it? No, you didn't like it either, huh?
The first part I just
All right. It says the following table gives velocity in the vertical direction of a rider on a Ferris wheel at the amusement park. The time t is measured in seconds after the ride starts, and it's in one continuous revolution. During what time interval is the acceleration negative? So we have a velocity, correct? Look at your velocity. From 0 to 0, is the velocity getting, where is the velocity decreasing? When the velocity decreases, isn't the second derivative negative? So I would say 15 to 30. Where else does the velocity decrease?
Wait, it's not negative.
No. Okay, so look at it this way. If you were going to find the slope of velocity, all right, and you've got 0, 1.6, 2.7, 3.1, 2.7. If I did this, 0 minus 1.6 is negative. And then if I did this one, 1.6 minus 2.7 is negative. And if I did this one, this would be 2.7 minus 3.1. All of those are going to be negative derivatives, all right? So then, because it's decreasing, what's happening from negative 1.6 to negative on the interval 35 to 45? No, wait a minute. But this is the feet above the ground. You're negative 1.6 feet above the ground. Now you're negative 2.7 feet. If we do the slope, what's negative 3.1 minus a minus 2.7? No. The negative is bigger than the positive, so you're decreasing on 35 to 45 also. What is the average acceleration? Average acceleration, you should have gotten that. It should have been, during the first 15 seconds, you should have done 3.1 minus 0 over 15 minus 0. That's minus, is 31 over 150, which is whatever. Now it says approximate from 0 to 30 using Riemann sum of 6 intervals. So how do you do that? Draw a picture. You know how to do that. What does the approximation in part C represent? That's the area under the curve. What is velocity?
Wait, what is number D?
Is that the first derivative? Right? Velocity is the first derivative. So what is the area under the curve going to represent? It's the original. What's the original? Position. So basically, that is going to tell you the position at the end of 30 seconds.
Wait, why is that position?
But I probably would not ask you that question on the exam because we haven't gone over that enough.
Oh, okay.
Because if this is derivative, the area under the curve is one function before that. So that would be original. All right.
See, how could we see like left, right?
They told you left on this one. Oh, they didn't, of equal length. My guess is that it would have been the same. If they did not tell you, it would have come out the same. Symmetric, again. If we look at page 216, this definitely, I would like to take time to do this. This is definitely within our realm, I believe, for free responses on this test. We have f of x to be a times 7 minus x squared. A is greater than 0, so A should be positive. Find A Find in terms of a, that means a should still be in the function, the equation of the line tangent at x equal -1. What is my y value? What's my y value? What's f of -1? 7 minus 1 squared. How about 6a? All right. What's my slope at -1? What's is this a product rule? No. So there's my slope function. So the slope at -1 is going to be 2a. So if I were writing the equation, I'd say y minus 6a is equal to slope times x minus the a. Find in terms of a, again, we're going to have a, is the y-intercept of the tangent line. So now I have to go further. So I distribute, I get 2ax plus 2a. Now I'm going to add 6a. What is my y-intercept going to be? 8a. I just distributed and put it in slope-intercept form to find my intercept. Find the x-intercept of the tangent line. X-intercept means y is 0. So if I put 0 in here, I'll have 0 equals 2ax plus 8a. So negative 8a is equal to 2ax. Divide by 2x, what is 8 or x equal to? -4. So your x-intercept is -4. In terms of a, the area enclosed by the graph and the tangent line and the y-axis, D you could not do, but I only asked you to do A through C. All right, so your AP style, curve style sketch worksheet is new, relatively current. There's IVT and average rate of change tabular form. Hopefully those worksheets are still online. And then you have 2 problems from the textbook. So tomorrow we'll go over the 2 problems from the textbook, and then we'll look at that AV.
Oh, Miss Bryan.
Thank you, yes.
You gave me a 0 on the 847 finish, but here you have it signed and you like
You
graded
didn't
it.
pull it out. Yes. So we are turning A63 in. You will have it back tomorrow. A63 needs to be turned in.